Hello, I'm Nadia Houti, a research intern at Polytechnic Montreal, and my project is on the modeling and control of an active ankle exoskeleton for pediatric rehabilitation. So my project stems from the work on the Pearl exoskeleton, and as a prototype for this particular exoskeleton has already been developed, my project focuses more on the control aspect, mainly on creating a completely virtual model of the exoskeleton and its control system. Excessive human exoskeleton interaction forces can cause discomfort to patients during rehabilitation, and for this exact reason, control systems with appropriate feedback need to be developed to reduce these interaction forces as needed. Currently, the control systems of exoskeletons that have already been developed, which often utilize either an impedance or an admittance control, tend to be modeled by complex mathematical equations, especially for their dynamics and kinematics. For this project, the aim is to model the control system using Simulink, and this allows for a relatively simpler method for trajectory planning and torque control, for the model to be flexibly tailored to the available parameters in the exoskeleton, and most importantly, for virtual tests to be conducted on the exoskeleton so that factors such as safety and comfort can be reasonably predicted in the exoskeleton before tests are conducted physically on patients. In summary, this control system includes an impedance control model, a torque controller, the series elastic actuator dynamics, and the exoskeleton outputs. Inner loops would provide feedback to recalculate trajectory accordingly when human exoskeleton interaction forces are excessive. Ideally, the exoskeleton would rotate about its only revolute joint in a manner that follows the reference trajectory as closely as possible. With this, we aim to develop a control system for the exoskeleton that is relatively easy to implement, an exoskeleton that can adapt to the patient's motor performance, and most importantly, a more comfortable and wearable exoskeleton for the patient. Thank you.